Hello everyone, welcome to this discussion where we are looking at this problem under simple harmonic motion, and the question reads: a particle is executing simple harmonic motion. What fraction of its energy, by this we mean the total energy altogether, is kinetic? So meaning that we're looking at the fraction where we have a part of kinetic energy from the total energy. That is when the displacement is half the amplitude. So let's see how we can go about it. Now here we are going to assign a symbol, this one, as the fraction. So this is a fraction of the kinetic energy divided by the total energy. So what we're going to do is we first have to find the kinetic energy. After finding the kinetic energy, also find the total energy. Then we divide. What we obtain simply the fraction. And the condition we're given is that the displacement is said to be half of that over the amplitude. Alright, so let's find the kinetic energy. So here we have that kinetic energy is half mv squared. Now this is kinetic energy. That's how you calculate the kinetic energy. But here we are considering the movement. The movement is simple harmonic motion, hence it is periodic. That is to say, we need to know the actual formula for a particle undergoing simple harmonic motion. Now here we are not given this at mean position, hence it means that it's just at any point of the motion. So if that's the case, to find velocity at any point, velocity at any point is calculated as v is equals to root of k over m. Then we have a squared, which is amplitude, minus x squared, which simply represents the displacement. Now we know to say this is the same as saying v is equals to, from the laws of surds in mathematics, we can split the root and say k over m. This is multiplying with the root of what we are left with, which is a squared minus x squared. Now again, if you recall, this part that we have here is simply the same as angular frequency. So this is also an expression for angular frequency. Hence velocity will be equals to, here substitute with angular frequency, then you say root of a squared minus x squared. So now this is what we're going to substitute where there's v. Hence we get our kinetic energy to be equal to half mass, while there's v replaced with this, now our v squared, then even this will be this will also be squared. Okay, so our kinetic energy is equal to half the mass. So everything in this parenthesis to be squared, it means that our angular will be squared. Then when you square the square root, you just obtain what is in the root, which is a squared minus x squared, like this. Now we need to remember that there's a condition we've been given. The condition is that the displacement is half of the amplitude, meaning that our x will be equals to a over 2, meaning that half of the amplitude. If this is the case, it means that if we square x, since you have a square, it means that this will be a squared over 2 squared, just 4. So now we'll come and substitute this where there's x squared. This therefore means that our kinetic energy is equals to half mass times angular frequency squared multiplied by a squared minus a squared divided by 4, like this. So we proceed with our problem. This is equals to half mass angular frequency squared Now when you work this out, we can do a rough working for this, that we have in brackets. So find common denominator, which happens to be 4. 1 into 4 is 4 times a squared, that is 4a squared, minus 4 into 4, 1 times that gives us a squared. Then 4a squared minus a squared gives us 3a squared divided by 4. So this is what we have here inside brackets, 3a squared divided by 4. So I'll take this. Okay, now what do we do next? We're going to multiply. We say 1 times 3, we have 3. Then we have mass. Then we can write a first, then angular frequency squared, being that multiplication is commutative. Then we say over, when we multiply 2 and 4 we get 8. Hence this is our kinetic energy. Now we now need to find the total energy. So total energy is simply given as half ka squared. Okay, this is what we have. Now recall that angular frequency is the same as the root of k over m, which means that if we square this, we'll have to square the other side because we want to make k subject. Then this means that angular squared is equals to k over m. Now as you can see, k, we have it here, so make it subject to the formula. Then we have k to be equals to angular frequency squared mass, which you can still write as mass angular frequency squared. Now what do you do? We now have that the total energy is equal to half mass angular frequency squared, then amplitude squared, like this. Alright, so now we proceed with finding our fraction, which is simply the ratio of the kinetic energy divided by the total energy. Does not say it's a ratio, hence we'll have no units. So what did we find for the total, for the kinetic energy? Well, that the kinetic energy is here. This is 3 mass amplitude squared angular frequency squared. This is divided by 8. Okay, then we say divided by total energy is half mass angular frequency squared amplitude squared. Alright, so the fraction comes out to be 3ma squared omega squared divided by 8. Now here we reciprocate when you change this to multiplication, hence 2 goes on top, divided by m amplitude squared angular frequency squared. Alright, now you notice to say this part and that are the same, hence they'll cancel. Then 2 can go into 8 4 times. On top we're left with the 3, down we have the 4, and this is the fraction, like this. And this therefore means that we have